Alright everybody, welcome. We are going to be going over this problem I gave you on Tuesday. Here is the problem from the board, trying to figure out which is the limiting reactant. Don't forget those three basic steps. First of all, find the number of moles. Divide everything by the coefficient from the balanced chemical equation. And the smallest number you get there identifies what the limiting reactant is. So first thing we need to do then is to balance this chemical equation, which is not too difficult. I believe if we just put a 3 there, a 2 there, and a 4 there, that just works. So that's the first step done in terms of balancing it. Now I just need to start by finding the number of moles of both iron and oxygen. Here we go. So first thing first, divide everything by the molecular mass to change mass into moles. Here's my answers. Done. And now I need to divide those by the coefficients. In other words, divide it by 4 or divide it by 3. So I'm going to do that there. And I see that this one, in other words, iron, is my limiting reactant, which means that oxygen is my excess reactant. I have too much of it. Okay, so that is basically all I do to figure out my starting point, the one that I really care about. I don't care about how much oxygen I have because there's too much of it. It's the 11.5 grams of iron. That's what's going to determine how much iron 2 or Fe2O3 I'm going to be making. So in essence then, I'm starting this problem over again, but I know where to start. I'm going to ignore this, and I'm going to go, okay, I have 11.5 grams of iron. That is my starting point. I'm going to convert it to grams of Fe2O3, so just like we normally would for these kinds of problems. So start off by converting to moles. Next step, multiply by the mole ratio. And finally, multiply by the molecular mass of Fe2O3. And that gives you your answer, 16.4 grams. Okay, now let's just say that you made a mistake, and when you, or you didn't know which one was limiting reactant, you couldn't figure out which one to use. Let's say you, instead of starting with the 11.5, let's say you started with the 9.05. Okay, the 9.05 grams of O2. What would have happened there? Well, if you would have done the calculation with these other numbers, crossing all my units here, moles and moles, I'm left with grams of Fe2O3 again, but look at the number I get, 30.1 grams. Now, why is this the wrong number, 30.1 grams? Well, first of all, look at the total mass of my reactants. It's about 20 grams. There's no way in the world I can get 30 grams of iron from 20 grams, or sorry, iron 3 oxide from 20 grams of its components. So that can't be right. And just that, basically that's it. The other thing you could just think about this is that if you can do it both ways and pick the lower number, that's the one that's going to be that goes along with that whole limiting reactant sort of idea, that the least amount that can be created, if you use up all of one of the reactants, that's how much will be produced. So because I figured it out twice, 16.4 is smaller than 30.1, so that's going to be the answer. So you can do it that way as well. Lots of ways you can look at that. But there you go, that's the solution. We'll do more of these in class on Thursday.